let's take a look at electron configurations. Electrons, you should already know, are found on the outside of the atom. The nucleus, of course, is in the center that contains protons and neutrons. For electrons, you also need to know the layout of electrons on a basic level, meaning how many are closest to the nucleus, and then as you move further and further from the nucleus, you add more electrons. So, let's check out these questions. First question says, write the ground state electron configuration for calcium. Ground state means that the electrons are in the lowest energy levels available. Now, if you are a New York student, you have the New York State reference tables you can refer to. So you go ahead and find calcium on the table, and here it is. If I blow it up a little bit, you'll see underneath the atomic number is the electron configuration. Now granted, it's a little blurry here. You should refer to your reference table, and the answer then, I'm just going to copy it. It's 2882, meaning 2 electrons, reading it from left to right, is closest to the nucleus. Then we have 8 electrons, another 8, and then finally 2 furthest away from the nucleus. Those are the valence electrons. So how many valence electrons does calcium have? It has 2. And then what shell are these valence electrons found in? Well, just number them. This is shell 1, 2, 3, and 4. So they're found in shell number 4. Let's take a look at the next question. Based on an atom's electron configuration of 2871, identify the element and whether or not it's in the ground state or the excited state. Okay, so this is a 2-part question. First thing is identify the element. Now, you're told it's an atom. You know protons are equal to electrons for an atom. So just add them up. 2 plus 8 is 10, plus 7, of course, is 17, plus 1. So I'm looking at an element, an atom of an element, with 18 electrons, but then also 18 protons. So don't guess. Go right to the periodic table. Let me put this back. And I'm looking for element 18. And, of course, I can't move this thing around. So wait 1 sec, and let's see. Hold on. Okay, that interruption, a phone call, taken care of. We're looking for element 18. I put the periodic table back, and here it is. Right? 18 is argon. So, going back to our answer, the element is argon. Now, it says we have to decide whether or not this atom is in the ground or the excited state. Now, you got to know what they mean. Remember, ground state means that the electrons are filling the lowest energy levels available. Excited state means that you have 1 or more electrons that are in a higher state than where they're supposed to be. Personally, the easiest way to do this, take the guesswork out, is go back to the periodic table. Again, I apologize. I'm going to blow this up a little bit. You're not going to be able to see it so great. In fact, you can hardly see it at all. But under the 18, what you have there is the electron configuration for argon of 2-8-8. And what that means is, again, 2-8-8 means the electrons are in the lowest energy levels. That does not match what was given, so therefore it's got to be the excited state. You have the promotion of one of the electrons here in the valence shell that has moved out. So use the electron configurations that are on the periodic table. They're all ground state electron configurations, and play the matching game. All right, and let's take a look at the last one. We have an ion of sodium. So we have sodium with a plus. That means it's lost 1 electron. And this has the same electron configuration then as what atom in the ground state? Well, sodium, if I go back to the periodic table, and of course now I have to scrunch this back down. Let's do that, and I'm going to move it over. Sodium is all the way to the left. It is element 11. So it typically has 11 protons, right? And of course 11 electrons if it was an atom, but it's an ion. And it has a +1. So it's lost 1 electron. So instead of having the electron configuration here of 2, 8, and 1, that 1 is gone. So we have 2, 8. That adds up to 10. And literally what that means is we're dealing with element 10. If you don't know what it is, let me spin this around, see if I can get you a little bit dizzy. We come back, and here it is. Element 10 is neon. And that is our answer. So an ion of sodium plus has the same electron configuration as neon in the ground state. Keep working hard, practice questions, know your definitions, and good luck.